Hi everyone, good morning, good afternoon, good evening, wherever you may be in the world. Welcome to this latest AMS Evolution live stream, talking today about connected factory, connected supply chains. We live, it's fair to say, in a VUCA world, but also one which is increasingly in the automotive manufacturing space, increasingly connected, enriched through data, captured via the cloud, on the edge, move through data analytics, giving us opportunities to get, move faster to market, digitalize processes, and plan more efficiently. We're seeing increasingly the rise of digital twins and digital simulation to plan for manufacturing before implementation, and also means often driven by AI and machine learning to optimize planning processes. And that's some of what we're going to be talking to today. Of course, as I just mentioned, in an increasingly disrupted supply chain, some might even say chaotic world that we live in, looking for this predictability is increasingly a strategic advantage for automotive manufacturers. But as we know, it's not always that easy. And it requires investments, it requires a collection of data, understanding the right data points, and of course, integrating that across enterprises to enable things like capacity planning and things like manufacturing engineering planning. So we've got a couple of great experts today that are going to talk us through some of the advantages on that, or some of the key areas. So I'm going to shortly introduce them, but first, just again, to welcome you on behalf of Automotive Manufacturing Solutions and our ongoing series of live streams and virtual events and physical events, bringing you content on the topics that matter most in the industry today. As I said, today, is all about harnessing data and connectivity to increase predictability and speed up processes, and to leverage these connected assets that we increasingly see in the manufacturing space. And twins, as mentioned as well, opportunities for things like predictive maintenance, integrated capacity planning, and as also mentioned, looking further at artificial intelligence and machine learning-based solutions, although, it should be said, not everything requires an AI solution. I'm sure we'll talk some about that as well. So how do we seek predictability in the age of disruption? I will shortly be bringing on some of our guests today, but I wanted to just tell you a few words about each of them. We're very pleased that they both could take some time to speak to our global audience today and also take some questions. We'll shortly be joined by Dr. Balakrishnan Adhi from Ford. He's known as Bala, so that's why I'll be referring to mainly as Bala today. He is Vice President, Material Planning and Logistics for Plant Operations, Material Flow and Packaging Engineering across the international market groups at Ford, and as we'll hear, that includes production in some key emerging regions in India, Southeast Asia, Africa, and South America, but also coordinating at a global level. Has more than 20 years experience at Ford and has also worked across regions like China as well. After Bala, we're also very glad that Alexander Neb is able to join us. He has been for the past 5 years part of project leader for the Production and Automation Technology Department of Robots and Assistive Systems at Fraunhofer, IPA, a very important research organization, the largest really when it comes to the manufacturing and engineering space. But as we're going to hear, as part of Fraunhofer and research and partners there, also has founded a startup in a very interesting space that I'm going to let him talk more about, and we're going to have the opportunity to gain some questions about. So that's our panel for today, and as I said, plenty of room for Q&A. A quick note before I turn to the first guest is that all the presentations that you see today are already available for you to download. If you scroll down to the handout section on your control panel, you'll see handouts. So the PDFs are there, you can take them home with you immediately. And of course, you can put any of your questions through to the panel, either during their presentations or during our live Q&A, which will immediately follow. But for now, I'd like to invite Dr. Balakrishnan, Bala from Ford, to join us. Hi, Bala. Good evening to you there in India.
Hi, good afternoon, Chris, and good day to the viewers. And really happy to join. And once again, thanks to Automotive Manufacturing Solutions for inviting me for this discussion.
That's our pleasure. So, so as mentioned, I'm going to hand over to you now, Bala, and then, but we'll have you back as well for some Q&A later. So, but for now, it's over to you.
Sure, thank you. If you just go to the next slide, Chris. So what I'm trying to share here today, considering the topic, the connectivity, and the solutions, what we are trying to bring. I'm in the supply chain management area, and clearly the disruptions that we are going through, what Chris has indicated, the VUCA world, volatility, uncertainty, complexity, and ambiguity, right? So also we in manufacturing and in industry, where we are clearly looking a shift from industry 4 to industry 5. Industry 4 is more like a technology driven, whereas industry 5 is more like a value driven, and which involves a lot of collaboration. When I say collaboration, it is more the human to machine interface and how we can maximize the interface, which brings a lot of value to the industry. Now, to tackle the disruption, what is there in my mind, 2 to 3 key things, what is listed here. The one is the multi-tier supply chain transparency. So we have serious semiconductor chips and other constraints that going across in automotive industry. Not only automotive is one of the industry going through the chips constraints. So clearly that's an area where how to bring the transparency across the tiers, the supply chain tiers, which is global in nature, and it helps to drive towards the industry 5. The second, on the new product development, we have a significant focus how to reduce the overall product development lead time and bring the technologies such as 3D printing or additive manufacturing. Again, this technology helps not only in the manufacturing space, even the design concept, prototyping, manufacturing, and the service. The entire end-to-end phase, we can make use of such 3D printing aspect, which helps to reduce the overall product developmental lead time. The last piece is digital twin and how it is getting applied in shop floor and as well as in supply chain areas. Given some example, I want to pick one or two basically. So in case of shop floor, how it gets connected with the energy conservation processes, so we can do a lot of simulation trials and then do the testing so that it clears the execution without any bottlenecks. And big data analytics assessment also helps the demand forecasting, especially in the COVID scenario, the trend and the using the data of the historical, as well as how we can predict and prescribe the futuristic scenario. So that is the key action. Next slide, Chris. So we see digitalization journey now near far. You can see right from the simulation and to the cloud, and in the far end we have AI ML enabled RPAs and connected shipments. There is a lot of systems, technologies, all that is coming in, and important piece in bringing all the technology is also an adaptability. So how far it can be adaptable into the workforce, which is absolutely critical and essential. And you see to increase the customer experience in terms of traceability, mobility, connectivity, visibility, and on real-time basis, these connected features, connected systems and processes across the entire ecosystem helps a lot. That's the journey that automotive industry in general is heading towards. Next slide. Yes, thank you. I also want to share a couple of publications that I did recently. One is on the digital technologies and supply chain resilience. So what is the, because when you say resilience, when we were thinking the lean concept, now there is a need for balancing the lean and resilience. So we were having a very good assessment, and this paper may help the viewers to understand better in terms of resilience in emerging market sector, automotive sector. Also, the second paper talks about the transparency for sustainability. So we were talking a lot of dimensions, the framework, what is there in the academic world versus how it is practiced in industry. So I think it was again intervention-based research. So I encourage the viewers can look into it, and yeah, that's the key updates I want to share. Chris, over to you. Thank you.
Thank you very much, Bala. That's very interesting, and thanks again as well for sharing those links. We'll make sure to put them in as well into the chat so that the viewers can see that. Thanks again, Bala. So we're gonna bring you back online shortly after the next presentation for the Q&A. And before I bring on our next guest, though, I just wanted to give you all, if you're interested in the connected supply chain and the future possibilities of supply chain, encourage you, and if you're a German speaker, encourage you to join one of our sister publications, live stream expert talks next week on July 8th. This is the supply chain under pressure, and it features some really great speakers, including Marco Weishaar, who until recently was leading the supply chain at Ineos Automotive, and is now a consultant in the industry, and also some experts from software companies, and also indeed from Dassault. So there's a link that's just been popped into the chat for you, and that we just encourage you, if you want to join that next week, it's free to join. For now, though, what I'd like to do is bring on shortly our next guest. He is, as I mentioned, manufacturing expert from Fraunhofer, but has recently also founded another company. So I'd like to invite Alexander Nib to join us, share some insights and from research done at Fraunhofer, and also some exciting areas around automotive planning. And there we are, we have the presentation up. Alexander, over to you.
Perfect, thank you. Yeah, my name is Alexander Neb, and right now I have kind of two jobs. I'm ending my first job at Fraunhofer IPA in Stuttgart, Germany, by the Fraunhofer Gesellschaft, which is the biggest research institute in the whole world. And yeah, next to it, I built up my own company, and I'm the CEO and founder of Arcade Assembly Systems. And we have the first assembly planning software on the market. Yeah, but first things first, let's talk about the problem. What's the problem? We have a very inefficient assembly planning. Why? Because what do you do in the assembly planning? We have screenshots and Microsoft Word. Sorry, the slides in German, these pictures, nevertheless, I talk you through. So how does everything begin? It begins with a CAD model from the designer. The designer defined the model. It takes years. Small products need months. And then what do we do with the models? Nothing. We make screenshots. We get Excel sheets with bill of materials. That means a part list. And of course, a lot of talking, a lot of meetings. And in the end, we need to define everything. We have to gather all the information. For big product, that can take months to gather everything. And then there is a lucky chap, the assembly planner, who has to plan the whole assembly thing. That means put everything together, put the expensive parts together. And why is he doing that? Because he needs an assembly instruction. Why? Because on one side, if you sell a product which is not assembled, you have to give an assembly instruction. Otherwise, you would have a defect, a product defect. In Germany, for example, that's defined in the German civil code. Yeah, but yeah, that's actually in every country that way. But on the other side, you need it also for internal processes. For example, you need to define how to assemble it, which way to assemble it, what tools do you need? You need to give it to your foreman, to your operator, your worker, and so on, because that's a really important document to plan the whole assembly. Yeah, but as you can see, it's extremely time and cost intensive. And Let's have a look on the numbers. Up to 50% adjust the production time, so time. 20% of the total product cost, just the assembly planning, including marketing and everything else. Yeah, 30 to 50% of the employee costs, yeah, are based on assembly planning. Yeah, that's actually a lot if you think about it. So we started in our research an approach how to solve this problem. How can we get from the CAD model directly to an assembly instruction, all the assembly information you need? And that's all under the topic of my PhD and several projects. The topic was the automatic generation of assembly sequences. Yeah, how do we do it? A few years ago, there was actually just one approach to analyze 3D models. That's the so-called disassembly approach. How does it work? You move things around until they leave some constraints. Yeah, it's a pretty easy approach. It's a pretty old approach. There are newer approaches using AI, for example, with random tree algorithms and so on. Yeah, it's pretty easy if you think about it. However, you also don't get a lot of information out of it. You can just find contact relations. You have a high computing time, and to be honest, it's a real old technology. And then I searched, are there any alternatives? And I found a possibility to use features. That's called a feature-based approach. CAD systems are feature-based. That means they contain a lot of parts called features, and you can define them about them. Yeah, nevertheless, that was till this day very complex. There was no solution at all to find the required features. So just because there is no solution, that doesn't mean it has to stay that way. So my target was to use a feature-based approach to define all required assembly features to define an assembly, and I did it. I published it in 2019, and now it's the first and only approach to generate all required assembly features, low-level features, geometrical features, and so on, to define assembly processes. Okay, how did I do that? How does it look? In my first approach, I accessed the 3D model directly in the CAD system through several APIs. And then I extracted the relevant information. For example, the contact information. That might means constraints. Is there a plane contact, concentric contact? What's the assembly direction? Then part information. That means is there any standard? Can I see the color of the parts, the weight, the material, even to read out if you find the standard to define the tools you need. For example, SW10 is the wrench size, for example. So you can find also the wrench size, the tools you need to assemble things. Then there are geometrical restrictions, because some parts has to be assembled before other parts can be assembled, and you have to know that before you assemble them. And at last but not least, the gravity direction, because the gravity plays also a major role in the assembly planning, and of course we have to put them in. Then our next approach was to adapt all this system, the feature-based approach, into a step-based approach. A step file is a neutral file which can be generated from every CAD system on the world. So how does a step file look like? It looks like on the left side, for example, here you can see a part that's called the Cranfield assembly benchmark. It's a robot benchmark part. And the Cranfield assembly benchmark is made of 13,437 low-level features. And we combine these low-level features, as you can see here, to generate higher ranked features. That means if we combine all these green features here together, we get a closed shell. In that case, that is a plane feature. That means that just a plane contact with no dimension or something. And we combine all these features first from a rule-based approach, and then feed it to an AI, and the AI is then defining all the required assembly information. Yeah, that was our approach, and then we started our own company called Arcade Assembly Systems. What do we do and how do we do it? First, as I told, there is a 3D analysis AI. We read in a step file and nothing else, just a regular step file of an assembly. The AI analyzes everything, and then we get structured assembly information out of it. Yeah, with them we can define what assemblies we have, what kind of assembly there is. You can define the tools, the geometrical restrictions, the direction, assembly direction, and so on. However, we don't throw it just into the planner. No, we give them another tool. Another tool is the so-called assembly composer, and the person can define the assembly sequence with the assembly creator, and it's made like a game. Like a game, you click everything through. For example, it's like it's like Lego. You have Lego on your screen. It's already built Lego, and you click on every part and disassemble everything. And based on that, you generate the assembly sequence. It's very fast, and you can generate fully automatically assembly videos and an assembly documentation. That means a step-by-step documentation. Yeah, it's pretty easy. And right now, first studies showed we are right now 92% faster than the state of the art by using the assembly composer. And then our next step is our so-called KIM, our KI montage assistance, which is in English an AI assembly assistant. Maybe we call our English version Kai. Let's see. And that's the first assembly assistant for the production, which is generated fully automatically, completely automatically, without any manual input, directly out of the sequence creator. And everything is set up in a server and web application. That means there is no IT, no installation. You can use it directly on demand. Yeah, that's how it looks like. For example, here is the planner planning the assembly, and there is the operator. And if something changes on his screen, the worker will also see the changes. Here, the worker uses an augmented reality device, which is nice, but augmented reality is not yet ready for the production. Here you can see a video how the tool looks like. On the left, you see the tree, the part tree of the CAD system. Then you can move things out. If you use the AI, I don't know why he doesn't, everything moves directly in the right direction. So you put things out, name your steps, and that's actually it. And if you click on play, you can see directly the automatically generated visualizations, how everything should look like. Here you can see, oh, the planner did something wrong. So yeah, no problem. You can change it, just drag and drop, and everything is right again. So by using this approach, we're, as I told, 92% faster than the state of the art. And here you can see how it looks like after 3 minutes. You have the full assembly here. Everything moves to the right direction. Everything is seen from the right angle, so the user can always see everything and nothing is hidden. Yeah, it takes us 3 minutes to click everything through, and the result is an assembly video, a full video, and an assembly instruction, step-by-step, automatically generated. And that's what we do at Arcade. Thank you for your attention.
Thank you, Alex. That's apologies for the delay there. That is. I think you perfectly described the problem that that the industry is facing there. Obviously, the inefficiencies that come in the manual process, but there with a really clear opportunity to use data and AI. I like Kim, by the way, as a product name there. I think that's one definitely to consider. Okay. We will soon. I think we'll shortly. I want to bring Bala back on for some Q&A, but just another quick flash for our audience about something else coming up on AMS next month, for which perhaps some of Alex's solution plays a role too. We're looking at how EV powertrains will and are reshaping automotive production. We're going to have some data from our analyst Daniel Harrison talking about the rollout of gigafactories and battery cell production, and how the battery cell and pack are changing the way automotive manufacturing operates across the industry and regions. And there, once again, we have a link in the chat for you to register for free and join us then on July 28th. But back to the matter at hand, I'd like to invite Bala back to join us for the Q&A. Bala, good to see you. Thanks again to both for sharing your insights and giving our audience a good grounding of some of the opportunities that they face. So some questions we want to go through with both of you now, and open for our audience as well to jump in at any point, and I'll bring that in. But I'm going to start with you, Bala. Let's I wanted to kind of zoom back or zoom in perhaps to the international market group a little bit, and the way you're approaching some of these digitalization topics at Ford. Obviously, the regions in which you have operated and responsibilities for directly, as I mentioned in the beginning, include India, Thailand, South Africa, Argentina, markets like this. But of course, some of these trends you're pointing to are highly global, and you want to scale and leverage things globally too. Can you talk a little bit about how that works between Ford's global operations and manufacturing and logistics versus how you're doing it in these regions?
No, it's a very good question, Chris. In fact, if you see the couple of examples I just shared in my first slide, which is on the multi-tier supply chain management, it's a global concern, right? So the products are common, they're designed at one place and manufactured at different locations. But it is all about when you source the part, when you understand your tier one, there will be a lot of commonality. And then how you go through all those requirements in terms of building the visibility across the tier X supply chain. So it's a global in nature. Whether you work in international markets or you work in North America or Europe, it doesn't make a big difference. But we clearly see most of the wafer, if you see on the semiconductor chips, the wafer and the chips mainly come from Taiwan and China and this side of the location. Though globally things are now the fab and the fabrication units are getting installed, but so that's where the role of the Center of Excellence, that what we call based out of India, where we do a lot of such activities engaging with the Ford global team. I see that's a global nature of work. Similarly, the technology piece, which I touched upon, the 3D printing, which is again the new product development, which is also a kind of a global nature. Again, it helps us to get the product on time. You may be having a local sourcing, but you want to do any, say, for example, a packaging trial, or you want to do any simulator during the process of product development, like prototyping and all that. So that is another way we can try to make it more a global tool, and the laboratories and design labs or manufacturing labs, those are all in a global nature. And that's where these tools and the research and engineering labs, all that is getting used in that lab. So I see purely from manufacturing side, I can clearly see if you come down to the plant level, that's where it differs from plant to, like a region to region. There may be some of the requirement, and down to the plant. If you want to pick a plant where something that you want to bring an improvement, then it's a business case driven decision where you can choose and decide what product that you manufacture and what suits for the plant. Those are all the local solutions. So that's how I differentiate between the global, regional, and local.
So definitely looking at the global scale, but we're acting locally for particular requirements and systems as well. Just on when we talk about areas like when we get into machine learning and AI, building data lakes, again, does that mostly fit more into the global approach, or is that again varied by region?
No, it places in all approach. I can say global, regional, and local. But if you, for example, in local, one advantage we have is we have a lot of low cost automation, the low cost IT solution. It suits the local market, what is there in already, the availability of the vendor and the good practices being followed. So what we try to do, we try to bring those solution and try it in one location, and if it is successful, then we scale it up. So that way also it works. So for example, it is not everything done in global and then it comes down to various plants. It is more like some selected plant can initiate an idea, and that gets scaled up at the global level. So that is also happening, especially in the AI ML space. How we can improve the overall value, right, from the business point of view. For example, we were looking, is there a balancing act that we can do between the freight as well as the inventory, as an example, right? Because outside situation is not so good with the disruptions we are going through. So if you want to manage how to handle that, so that type of decision, can we use some level of machine learning and AI approach to take care of what is the better inventory management model that we can keep and then handle effectively when you manage with your demand forecast. So those type of decisions, it is done in selected region, and then if it works well, we do a lot of experimentation in that space. That's where we are.
Yeah. Question actually for you, Alex, and it's one that I wanted you to talk more about, but our audience has also directly asked about it, is to talk a little bit more about how you get the data into your systems. The question is how you get the data assembly into your systems to create these modelings. You talked about the step file, that's basically the key as I understand it, but can you talk a bit more about the process and maybe expand that for a little bit more for our audience?
Sure. If you think about how you model things, the CAD system is feature-based. That means everything you do, even if you zoom in the model, that's a feature. You see a lot of data saved in the model. And there are very small features. For example, if you just want to get a line is made of 4 features. That's 2 points and 2 directions. And you combine them to a line. You have 4 lines, you combine it together to a dimensionless plane. Then you give it a dimension, you get a plane, and so on. So there are a lot of small features the planner don't see, and we are able to define all the features. Because, for example, the small part at Cranfield, that's about 40,000 features. A human cannot work with 40,000 features, and in reality, there are much more in the features than the feature itself. That means that's different levels of features. And the AI is just able to see more of these features, to read them, to understand them, and work with them. That's a thing a human couldn't do. And therefore, there are much more information in a 3D model than we thought the last 20 years.
Very interesting, and showed some impressive scope there. Is there, when we get into the machine learning AI part of it, is it a particular kind of approach that you've taken for that? Is it a neural network? Again, just to unpack this a little bit more for our audience.
Yeah, that's actually kind of a corporate secret, but it is. That's not just one AI. That's several AIs in several areas. For example, our biggest one, we call it the filter. That's a symbolic AI. It's a pretty easy approach. Let's call it like that. But just by filtering the information, feeding another system, that helps us a lot to reduce also the processing times. For example, our first approach took for an engine model 27 hours. Now it takes us 2 seconds because we optimized everything and used several eyes in the perfect field. But that's a corporate secret, sorry.
Absolutely understood, but we wouldn't be doing our job if we didn't try to to get some insights out of it. A couple more questions keep flowing in here from the audience, and I'm going to turn the next one to you, Bala. So you may have answered partly the question around where you talked about this localized approach, but the question was, how does Ford source data across factories and across the supply chain into a single platform to support the Industry 5.0 use case, digital twin use case? Now, I guess some of this is vision and still very much on the way. Is there any other tool or technology you would point to, or again, is it really that quite specific and specialized by region?
No, it is purely, I can say it's specialized by the region. I can say that, but let me understand the question again, what you are trying to say, which is more on the how the data flow and the relationship flow, you mean, from the supply base, which is going to.
If I understood it, I think our audience, so the question from the audience is literally how the data is sourced across the factories. And I mean, I guess perhaps that you talked, and in your slide, you talked about some near and far projects, a cloud data which is coming, a cloud layer which is coming. So maybe it's more to just unpack that a little bit, or is it many things at the edge, or making kind of so-called dumb assets smart to capture that data?
Yeah, basically, see, the data gets generated, right? So every transactions that what we are doing, the data is getting generated. For example, when we start sending the schedules to our supplier, there is a data, and then the supplier ships it back, there is a data. So I think everywhere data is that there's a massive data, and that's where the big data which we use to build the proper analytics and get some insights from the data on what way we can do. So we don't go and source the data anywhere outside the operations what we are managing. There is a clear data available, and now making use of the data, what way you can insight and try to come up with some kind of a quick decisions, right, using the data driven decisions. So for example, as a supply chain manager, we should be knowing what is happening now and what are we going to do in future. So you need to have both the side, now and future, right? So now you need to take immediate decision, because there is a big shift happening in industry. Like it's with the current constraints that we are going through, there is in industry side, the shift is moving from manufacturing to supply chain. Basically, based on what parts are available, then you start production. And in one way, you don't produce something without proper data or proper parts available, then it creates more confusion than stopping the production and ensure all the parts are there and then you produce, right? So these are all basic information and the data that what you're trying to get. And using that insight, you can decide and go and allow the production to happen. So those things are all connected, and it is getting into a, like we are doing a lot of baby steps in this type of aspects. So, but in future, definitely it is going to grow, and it will become more and more like a data driven. Hope that I answered the question.
No, you did. Maybe just a quick follow up on that is where do you see some of the main barriers to that? I mean, when you look across the vision, I'm sure there are many, but maybe a couple of barriers that we can address as an industry.
Yeah, I see. This is like I said, the collaboration, right? I mean, if you see, if we have a lack of shared vision, lack of capabilities, and also lack of resources available in the entire chain. Because if you want to, I'm just picking again the multi-tier example. If you really want to be in terms of getting more production and getting more collaboration in the entire ecosystem, you need to have a strong governance, and you also need to have an excellent transparency, okay, across the tier. Unless you have that, you won't be in a position to have a data rich approach to manage the business. Now the barrier, if there is a reluctance in sharing the data, or in terms of there is proper regulatory related aspects where you cannot share the data, there's a confidentiality and all that. Those are all a barrier which will not allow us to move forward in building the right collaboration and right integration. I think that's where I see some of the barrier will come up.
Absolutely.
And he's coming up.
Yeah, I can imagine. Alex, there's another audience question follow on to you, and it was, what is your approach on so-called flexible parts such as wire harnesses, adhesives? I suppose, you know, is this equally fast and adaptable for all different kinds of parts, or do some require different approaches in the modeling?
No, it does not. It depends on the companies. We had contact with some companies which designed the flexible parts, for example, wires. In that case, the wire is just a part. Our AI will give us, for example, two possible assembly direction, which is the front and the back of the cable. However, the user can define it by himself. But so it's easy to implement it. But not every company is designing cables. And in that case, you can have we call it a blanco process, and define everything manually. That means you can highlight some parts, put cable something in here and the other end in here, for example. So in that case, if you don't design them in a CAD system, you can use it. You can design it through notations in the assembly instruction.
Okay, and you know, not getting back into corporate secrets or anything like that, but you know, does this automation of the automation, so to speak, require continuous updates? You know, in terms of the algorithm, and just giving us a sense of how, again, without the details, how that works.
Yep, actually, no, it does not, because the step file is standardized after the ISO 10303. Unless the standard changes, we don't need to do any changes. Yeah, we change features. For example, we add constantly new features, new functionalities. For example, in the next weeks, we will also add a new function to recognize snap-on mountings, for example. And we find new possibilities to read out the features, to add new features, to find new assembly features, and so on. But unless the standard changes, we don't have to change our system.
Okay, interesting. Bala, going back to what I talked about right in the beginning and what you've picked on, and talking about this age of instability, disruption, unpredictability, and obviously when we talk about building a more predictable supply chain, within this we depend on a lot of historical data, and yet we live in a time when so much of what's happening has no real precedent. Is that something that also stands in the way of some of building kind of actionable solutions around this, or is in fact you're already seeing how the approach can help even in these wildly unpredictable times or unprecedented times?
No, I just want to just think through, see the automotive, when I joined in Ford way back in '99 versus now, the entire business model has changed. Okay, we are now moving towards mobility as a service, right? So where it is getting integrated with not OEMs and your TRX suppliers and software solution providers, logistics service providers, mobile network operators, its car is becoming more like a consumer product. Now, in order to build that type of product, you need to have a strong connection among all the stakeholders. And I think that's where your AI and ML plays a very, very important role in terms of building that connection and try to take those quick decisions and business decisions to run the operation to enable all the stakeholders connects well with each other. So I clearly see AI ML driven solution helps also agility with urgency. That's where we are heading towards, whatever that we are trying to do, and this is enabling, basically the AI ML solutions are enabling that, and it is much needed in the current scenario, because if you are going to have some of the challenges, and it is not only as a company can do, there is a need for a lot of collaboration with research firms, the universities, the startups. So those engagement and partnership also enables to get that done, because you cannot do everything in sourcing. You cannot do, because you need speed, and obviously the better way to is to do collaboration and build relationship and try to identify the solution to solve the problem. That's what I can think of.
Alex, another audience question for you is, how is the operator involved, and where do plan features get processed? So for example, fixed installation, combined processes with fasteners, etc. I suppose the question is, we see the assembly sequence planned. Is there an aspect to in which the plant layout design can be accounted for, or is that a feature that might come in future? So that's a question from the audience.
That will be a feature which come in the future, because will also plan the layouts with our tool. Yeah, we will define stations, for example, MTM analysis and so on. How many people are needed, which tools are needed, and it's kind of an auto generator. Yeah, that will come in the future. Yeah, right now we're searching for investors, because we sell more than we are able to provide, to be honest, and we need more people to work with us. But yeah, we have a lot of ideas. That's one of them, and also how to integrate the operator, for example. There is a feedback tool, so the operator can tell the engineers, "Hey guys, look at that. We can do it better that way. Look at that. There is a problem. If you don't do it properly, something could break, and so on." And the engineers can see that and can use this information or not. If they use it, they can change the model, can change information, put additional steps in or additional notations, and every system will be updated automatically. It doesn't matter if the plant is in Germany, the production can be everywhere. It doesn't matter. So a good idea can be rewarded everywhere.
Yeah, and I can see an iteration of this where then accounting for the other types of dynamic changes which might come, be it around capacity alignment, around things with suppliers, like we're talking about with Bala as well, can feed into a dynamic planning like that. Just kind of maybe on the point you raised in the research at Fraunhofer around this highly manual, processes of the automated assembly planning, or sorry, the lack of automation and assembly planning. You don't necessarily have to name names as such, but is that pretty much the case across the board, that it's the Word docs and the screenshots, etc., that you showed, or have there been steps into other areas of automation in this area?
What was the question?
Sorry, it's just because you obviously talked about how currently assembly planning is a very manual process.
Yeah.
And I'm just wondering if in your research that's been pretty much the case universally, or have you seen other areas where automotive manufacturers particularly have tried to move into this automation area?
Yeah, a lot of companies tried it, but a lot of failed. I could name a lot of companies which have a tool which promote doing it, but it doesn't. Yeah, and it doesn't sell very good. These companies are already in contact with me because they want to white label our product, and we're discussing now the terms. But in the manner of automating assembly planning, I think there are just two companies which have a tool like that, and that's Lego and IKEA. Okay. But these tools are very, very specific, and you cannot use the Lego tool for everything else, and vice versa. But that's actually it.
Well, if we get to the point of flat-packed cars at home, Billy bookshelf cars, maybe then we can give that to the industry. But as you say, that solution sounds pretty specific in that case. Bala, we do have a few more audience questions, but I'm turning to you again, Bala. You said in your slide there was you talked about a project with using IoT sensors to conserve energy in stamping presses, for example. That sounds like a very interesting use on the shop floor. Can you tell us a little bit more about that?
Yeah, it's a good question. Actually, the central energy plant in US recently brought the digital twin application in order to accurately detect the energy losses. Okay, in there some of their shop floor equipments. Also, it also helps to pinpoint where the energy can be conserved, right? When there are happening in the shop floor, and improve the overall performance of the production lines. So those are all some of the benefits we have seen, and we just try to pick that idea and try to bring it in one of our plant shop floor in terms of stamping presses, in terms of the powered metal handling vehicle, to see if you can fix some of the sensors, and will it be in a position to tell what is the energy current consumption. Okay, so because you need, that is absolutely critical in industry, like the energy cost is shooting up. How you bring down the energy cost by bringing these IoT sensors and improve the utilization. It need not be a bigger investment. It also helps to re-sequence the practices. I mean, re-look the current practices what we follow, or the processes that we have, like your shutdown time or your shift clearance, and those timing you can relook. By doing that, we can even bring a lot of energy conservation. So that is the kind of digital twin application basically helping us to drive how we can increase the innovation, I can say, within the shop floor. That's what I mean that IIoT driven application, Chris.
Yeah, interesting example. Alex, another question for you, going back to operators. So again, this might be a question for future, but the question is pointing out that the Toyota production system requires operators to write their own work instructions. So I guess, you know, the question again is, can your systems be used by operators in this sort of scenario? I'm not myself personally familiar with that requirement, but this is obviously an interesting element of the TPS.
And that's a fun element. So there are actually two answers. Yes, operators can use it because in our company, the benchmark of our system is actually my wife and my mother-in-law, a French teacher, and they are able to plan the assembly of a whole engine with 100-something parts. They were able to do that because this tool is very simple, very easy to use. So yeah, everyone can use this tool without expert knowledge. And yeah, that would be amazing if the people which in the end assemble the product would do the assembly instruction. However, they don't. I know this process from Toyota, it makes totally sense, but they really don't. And especially in a country like Germany, we plan everything in Germany, do everything in Germany, but the assembly is everywhere in the world, but Germany. And yeah, therefore, no, it's all done here in Germany from non-assembly experts, partly, I have to say, because a lot of people of them have to plan the assembly. It's a work no one really likes to do, and some people don't even saw a manual assembly line or how do they do it. And in my 5 years of Fraunhofer, I saw a lot of assemblies. I was there with the production planners. Some of them were quite shocked how they assemble a product because they do it totally different and so much better. Yeah, it would be amazing if these people would do the instruction, but that lies in the systems of every country, every company.
Okay, so we're coming close to the end. We have a few more minutes, and I'll take advantage of that whilst you're here, and there's still questions coming in. Maybe another one for you, Alex, and I think this has come up in terms of planning for automation processes, and I think we've spoken about this at least, that sometimes automation is planned where it's either not needed or doesn't end up being more efficient than a manual process might, or at least it adds other layers to it. Again, do you see this approach as a way, or potentially in future a way, to come to those realizations sooner than later?
Yes. We have also an add-on which will come in 2 years. It's called the Automation Potential Analysis, which was also developed from Fraunhofer. Yeah, first, before you think about automation, you have to think about the assembly, how to assemble it. And thinking about assembly, you can define good steps which are easy to assemble by looking, for example, at the features. Are there any barriers? Can I see everything? Which kind of robot path is needed, and so on? Can I get with my gripper into the parts, and so on? Are there some flexible parts in between, and so on? On all these analyzation can be done in the assembly planning, and assembly planning today is pretty late. If we start looking on these good processes already in the design, we can, even if it's just a note for the assembler, hey guys, look at that, that could be automated pretty easy. That's more than we have today. So yes, in the future we will have a tool, as I mentioned it, the Automation Potential Analysis, which could tell in the future how to assemble parts. But that's also a future project with Arcade and Fraunhofer.
Bala, from your side, when you're using digital twins or looking at potential digital twins, are you also exploring which aspects of material flow, for example, might be automated or not in the plants or in the logistics chain?
Yeah, I mean, not only digital twin. If you see digital twin is one of the application where it helps us to simulate and test and move forward to establish your future either product or service, right? the automation, what we are looking is we have multiple stages of automation. So robotic process automation, RPA, digital process automation, DPA, and then the enhanced AI ML driven automation, okay, RPA basically. So it's like evolution, and it's clear that we already do a lot of such RPAs and DPAs, which helps, and it's more like a how to automate your transactional work and taking care of repetitive work and try to get the insights for the employees or the workforce to take a decision, right? I think that is the level of RPAs we are doing, and that from the investment point of view, from the introduction of the new product perspective, yes, we do digital twin and more like a simulation and testing aspect. That's what currently we do more. And also, if you see in the overall scheme of things, I clearly see the way we are heading towards the automation and the cobot, because we call robot, and I see cobot also plays an important role where it performs with a collaboration with the human worker. So that's something as a next journey that we think it is going to hit us.
Okay, yep. So we're coming up on the hour, so I think I'd like to get some closing remarks from both of you. So and I want to kind of focus that around some of the next practical steps to achieve some of the goals that we've outlined over the last hour or so. So Alex, starting with you, what are the really next key steps for Arcade in terms of developing this product? You mentioned obviously the strive for investors. I'm sure that's a critical one, but when also we look at the technology development and what you want to see to achieve that, what's the key next steps for you?
Yeah, the next step will be our first project and the rollout of our technology, and we're right now overwhelmed. Last week there was the publication of our company. We have right now 80 companies which want to try out our tool. And yeah, that's the first step. Therefore, we need investors because we all need to roll out our technology and simultaneously add all the new features, all the ideas we have. And therefore, we're hiring right now. Yeah.
Okay, great. So next step is for those watching is potential, if not investors, then talent. So certainly opportunity to connect with Alex there, and that's an exciting journey indeed. And Bala, from you, kind of wrapping up, what are things that Ford needs most from its partners in manufacturing and the supply chain to achieve those near and far goals on your digitalization roadmap?
Yeah, two aspects I can think immediately. So one is the stronger integration, collaboration, and transparency. I think that is absolutely essential across the partnerships, suppliers, dealers, the entire chain. It is much important. And also, in order to bring the technologies, all this AI, ML, the evolution and all that, it is equally important how we upskill the team, how you bring the workforce, because you have 15-20 years average experienced resources in the plant. For the technology evolution going through, how are we going to bring them up, right? That is one of the key next step I can see, not only in Ford side, it is entire chain, your tier 1, tier 2, all the supply base. I think that pace is much needed. I think with that, we can build more connectivity and we can improve the whole ecosystem, in my perspective. Thank you, Chris.
Thank you, and a big thanks to both of you. So for taking all the time with us this afternoon and evening for you, Bala. Really fascinating. We've had lots of questions as come through. We will share this content also afterwards with our audience. Those of you watching, as said, the presentations are now downloadable and correctly. So if you're here, grab it. If you're watching this later on demand, they're also attached onto the web page. So have a look if you want more. And of course, feel free to get in touch with AMS for more, and as well as connect with our partners here and on our great guests. So Alex, thanks again so much. Bala, thank you again so much for for this time and answering all the questions as well.
Thank you.
With pleasure. Thank you.
Great. So just again for the audience, a couple of final things to leave you with to look ahead with things that are coming up. Again, looking on the supply chain side of things, AMS's partner, sister publication, Automotive Logistics. We have our largest global supply chain and logistics event coming up in Detroit in September, so you can be sure we'll be talking there as well about transparent supply chains and opportunities in that. Some great speakers lined up from the likes of General Motors, Nissan, and more. Link is in the chat. Early bird still applies, and it's complimentary for OEMs and tier one. So hope some of you who are watching might think to join us there as well. And those of you who were with us last month at the AMS Automotive Evolution Summit online, where we really had a fantastic lineup of speakers, all of that content is available for you to watch on demand on the AMS website. As part of our on-demand and spotlight section of the website. So again, another link has come through. Check it out. Some of the speakers you see there from the likes of BMW, ZF, who joined us, and Scania, Polestar, etc. Lots of great insight as well as reports on the AMS site. So hope you have some chance to look at that as well. And that, by the way, will lead to a physical event which we're launching for the first time this year in December 7th, in fact, in Munich at the Süddeutsche Zeitung headquarters. So more information on our website is coming imminently on that, but we've already got some of these speakers and others coming and joining, and we're talking more particularly about EV and battery manufacturing transformation across different parts of the production chain. So a lot of excitement to come. Hope you can join us then. It will also be a hybrid event. As again, just checking out some of the stuff on the AMS site, our latest digital edition. We've got a new one set to hit stands next week, so make sure you keep up with that. But there's already some great content, if you haven't checked that already, there for you. And that's it. That's it for us today, this month at AMS. But again, if you keep track on the Spotlight page, we've got more live streams to come. I talked about already the EV powertrain transformation coming up July 28th, as well as our partner events, which we outlined. So lots to come, lots to share with at this time of disruption, but also transformation. All of it's extremely positive, and we're so glad we can share it with you. So wishing you all the best, and look forward and wish you a great summer. Look forward to seeing you at one of our events or reading some of our content very soon. Thanks again.